Good morning, grade 11 students. This is Mrs. Pascale. Today's lesson is Factoring Quadratic Expressions, Chapter 4, Section 4.4. The objective of this section is to factorize all types of quadratic expressions. Today's section is basically a revision about all types of factorization took before of a quadratic expression. We'll start by finding a greatest common factor of an incomplete quadratic expression. What do we mean by an incomplete quadratic expression? When the expression contains only ax squared plus bx or ax squared plus c. So example 1, if the expression is 6n squared plus 9n, we have a common divisor between 6 and 9, which is 3, and a common variable with the least power n. So the factorized form will be 3n into 2n plus 3. Example 2, if we have minus x squared plus 3x, we don't have a common divisor in this expression, so we have only a common variable x, and the factorized form will be x into minus x plus 3. And finally, if we have the expression in the form 4x squared plus 4, so the common factor is only 4, and the expression is in the form 4 into x squared plus 1. Second way of factorization is using the remarkable identities, the three rules. The first one is the difference of two squares when we have any expression in the form a squared minus b squared. The factorization is a minus b into a plus b. So in order to factorize 4x squared minus 49, we take the square root of 4x squared, it gives 2x, and the square root of 49, it gives 7. So the factorization is 2x minus 7 into 2x plus 7. If we have a perfect trinomial, the sum of three terms in the form of a squared plus 2ab plus b squared, the factorization is a plus b to the power of 2. Example, 4x squared plus 24x plus 9. Also, we take the square root of the first term and the square root of the third term by taking the sign of the second term, and we get 2x plus 3 squared. Perfect trinomial also in the form a squared minus 2ab plus b squared is factorized in the form a minus b squared. Example, 4x squared minus 8x plus 1. So we take the square root of the first term, it's 2x, the square root of the last term, it's 1, and the sign of the middle term, it's negative, and we get 2x minus 1 squared. Let's move now to the third method using the quadratic formula. And don't forget that this way or method is the more efficient to find the roots of any quadratic expression and summarize all the previous methods. To use the quadratic formula, we need first to define the discriminant delta b squared minus 4ac. And following the values of delta, we have two ways of factorization. If delta is positive, then the equation admits two roots or two solutions or two values of x defined by x1 and x2 as shown. And then the factorized form is y equal a into x minus x1 into x minus x2, where a represents the leading term in any quadratic expression. Example, factorize y equal 4x squared plus 16x plus 7. First, we need to define delta. Delta in this example is equal to 144. It means it's positive. So directly we can define x1 and x2. And the factorized form will be y equal 4 into x plus 7 over 2, x plus half. Let's not forget that if the calculator is allowed to use, we can find directly the roots of any quadratic expressions by using mod 5(3) and introducing the real coefficients a, b, and c to the calculator. Then we get directly x1 and x2. If delta is negative, then the equation admits no real roots. We cannot define a value for x, so the expression cannot be factorized unless we have a common factor or common divisor. Example, when y equal x squared plus x plus 1, delta gives a negative value, so this expression cannot be factorized. If delta is equal to 0, then the equation admits one real root, or we call it one double root. Then the factorized form is always y equal a into x minus x1 square. Example, if y equal x squared plus 6x plus 9, we need to define delta that gives 0. So x1 is given by minus b over 2a and is equal to negative 3. And the final factorized form is y equal x plus 3 square.